Good morning, students. We have our sleeve bearing completely modeled and a view saved, ready to use in our drawing sheet. So in this second general portion of videos, we are going to take this 3D model and tell Solidworks to automatically create the 2D views that we're going to need to dimension and to place an isometric view on the drawing. We will in addition put some information in the title block and create a revision table. We'll break that into multiple chapters, and I think you will find that there's a lot of detail work, but a lot of that detail work is automated. So with that said, let's get to it. To create this drawing, we need to talk a little bit about file structure. And inside the Solidworks software, there are two separate and independent files for a drawing. One is the drawing file, and that drawing file contains links back to the part file. They are not the same file, and they are not intrinsically linked together. There literally is just a link path from the drawing back to the part file. So as you work in school, you are always going to want to make sure that if you're working on a project, your drawing file and your part files are in the same folder, and you are achieving the simplest path link possible by making sure they're in the same file. And so that's what we're always going to do. So to start here, I'm going to click File, Save As. I am going to navigate, if you see up here, up to Intro to Engineering Video Content, and I'm going to save my part file here. I'm replacing it. That just means I'm updating the file. And once that completes, I'm going to come up to the far left-hand corner of my screen, click on File, Make Drawing from Part. It's not a very intuitive command because I'm not really just making a drawing. I'm creating a whole new separate and independent file. And we'll see how this works. So we are going to choose a B-size landscape drawing title block. And B-size simply means that it's 2 times bigger than a normal sheet of paper. So this B-size is 11 inches tall, but it's 17 inches wide, or 2 times the width of an 8.5 by 11 sheet of paper. And over here on the right, automatically we see this view palette template, and we see a bunch of potential views that we can put onto our drawing sheet. Solidworks has already calculated what all of the orthographic views look like and some 3D views. I'm going to close this right now and just show us how that we can get into and out of this template. So I'm going to move my mouse left and just click into space, and that dialog box disappears. I have some menus over here on the right, and that view template is the 4th icon down or 3rd icon up from the bottom. It's called View Palette. And whenever I click on that icon, I bring my entire view palette back up, and I can click this green circular to refresh or automatically recalculate all of these views. Solidworks thinks for a second, does all the calculations, and all those views are up to date. So if one thing I want you to notice is here, this print ISO is the view that I saved in the last chapter. I'm going to take this view, click on it with my left mouse button, and drag it over into the lower left-hand corner of my drawing. When I drop it, the color disappears and it becomes lines. A basic tenet of technical drawing. It does not involve color, it doesn't involve shading, and it involves just black and white lines, or black lines, I guess. So we're going to cheat just a little bit. When I select this view on the left, I see all of the properties of that view. So I'm going to scroll down just a little bit, and because this is just a visual cue in this particular case for a machinist, I'm going to, under my display style, choose shaded. And I'm going to, because this is just a visual representation and I don't want it crowding up my drawing, I'm going to change the scale of this view. So I'll click on Use Custom Scale, click on my alternate arrow by 1 to 1, and choose 1 to 2. I'm going to click the green check, and I'm going to drag that view way down into the corner and give you a heads up that that's kind of a standard place to locate these reference 3D views for manufacturing somewhere. In general, for a drawing layout, we're going to put our bill of materials, if we need one, in the upper left. In every drawing, we need a revision table, and that's going to go in the upper right. And any kind of notes that we have are going to go in the bottom right, and they are going to start at 1, proceed up to 2, up to 3, up to 4. So we want to proceed with our note numbers going up so that if additional notes are needed later, they can be added above and without changing the entire organization of notes to add one more note at the bottom. So we have our first view in place. I'm going to click my green check, come back over to my view palette, and I'm going to choose this, let's see, I think right view. No, I'm going to choose the left view. I want to choose the view that has the front 6 holes closest to the edge. And I believe it's this left view in my project. So I'm going to click that, drag it over, and I'm going to drop it into place. And if I drag my mouse to the right just a little bit, Solidworks automatically tries to drop the next view over. And when I say next view, there's this thing called third angle projection. So it is the next third angle projection that would be referenced in that direction. If I drag my mouse down, I get a bottom view, a left view, a top view. And notice if I come off at an angle, I actually get a projected isometric view for that particular angle. So on the finished drawing sheet, you can see that I have a section view, but I'm not going to place this section view here. So I'm done. I'm going to click my green check, and from a basic building block standpoint, this is the only standard view that I want to drop in. So if we look at the finished drawing sheet, we can see that I have a number of hidden lines of where those 6 holes and pattern of 4 holes should be. I don't have to draw those. That is a view style. So if I click on my view, come over to display style, I'm going to ask Solidworks to have my hidden lines be visible by selecting the second option. I click that second option, and I automatically can, from a hidden line perspective, see all of the holes. If we look at the finished drawing, we also see that there are center lines coming through these hidden holes. I'm going to tell Solidworks to put them in using the center line command. It doesn't work very intuitively, but it's pretty quick. So I'm going to click center line. And instead of drawing anything, I'm going to select one edge of the hole and the second edge of the hole. And I've already got an assumed pattern of center lines that Solidworks is trying to anticipate what I want. It's exactly what I want, and I click my green check. I now need to break away a certain section of this part, and we will do that using the View Layout tool. So I'm going to come up here to click View Layout and click this option called Broken Out Section, and I'm going to have to draw an enclosed region that I want to break out. And it's a spline, so it's not individual line segments, so I don't get that really nice clean line break. But I'm going to do the best I can here and include this area of the part to break out. And Solidworks is going to ask me, how deep do I want to break it out? I click that. I come over to my depth by dimension, and I want to cut right through the midpoint of those first 6 holes, which is a distance from our drawing of 10 millimeters. So now I'm going to click preview, and supposedly that's what we're going to get, and I don't like that. I noticed that my units are in inches, so I just committed this huge mistake earlier. I started a new file and didn't focus on my units, origin, and precision. So I'm going to have to recover a little bit, which I guess is a good opportunity here to highlight how we can recover some things. So I am going to backspace over inches and type millimeters. And Solidworks has changed that number to 0.379 inches, or 3739, which is the conversion. And click OK, and we'll see what happens. And I actually break right through the center of those holes. Okay, so how do I recover and get back to this drawing being in millimeters? Same way as in a part file, I'm going to come down and click on my unit system. Right now it's inches, pounds, seconds. I'm going to say I want to edit my unit documents and click on millimeter, gram, second. And I'm going to look at my drawing, and I want my primary units in my drawing to actually have 0 decimal points precision. Notice that I've modeled with more precision than I'm going to dimension with. That's a really good practice to make sure that I don't have any rounding errors in my model. The model that I have is exactly what I want. So my dual dimension length really doesn't matter. My degrees that I use are going to have 0 decimal places of precision. And I think I'm ready to click OK. All right, so now we need this right-hand view over here. Although it's not an elevation or just a normal orthographic view, it's a section view, and so we're going to create it using this section view command. I'll click on section view, and notice I get a set of vertical lines. I can adjust what I want by choosing either vertical or horizontal over here in my properties. I do want vertical in this particular case. And here's kind of a beauty with Solidworks. It allows me to snap it exactly where I want, and the center of the part is what I want. And I'm going to click OK. It happens to be looking the correct direction. I'll come over to the right side of my part and click my brand new, completely drawn, and accurately drawn, by the way, section view. However, if you look at these section arrows along with my section blade, it does not look like the finished drawing that we are targeting. This is actually according to a standard that is derived for Europe, International Standards Organization. In the United States, what we're interested in is ANSI, American National Standards Institute, and Solidworks has a complete set of ANSI standards built into it. We just need to turn it on or change it from ISO. And that's done up here in settings, or options. I'm going to click that. I want to change my document properties, so I'll click on document properties. And the overall drafting standard is ISO right now, and I'm simply going to click my alternate arrow and say I want ANSI as my overall drafting standard. And I'll click OK. Notice the section blades and arrows and text automatically update, and that actually is according to an ANSI standard. So with just a few basic commands, all of the drawing views are completely done and accurate, and we haven't had to draw anything yet. So let's take one more step. Each drawing that is created requires a revision block. So let's put one in. I'm going to click Insert, Tables, and tell SolidWorks I want a revision table. SolidWorks asks me where do I want to put it. The standard location is the upper right. If I don't click to place it anywhere and I click on the green check mark, SolidWorks automatically places it into the standard position. Once I have my table, I can right-click on the table and say Insert, say Revision, and add a revision. Once I do that, I get a whole revision line called Revision A, and I get this little circle on my cursor that I can drag around for a while. If I click anywhere, I'm going to place a circle. I don't want to do that, and I will have explained why and what that circle is in class. In this particular case, I'm just going to move forward. I hit Escape, double click into my description box, and I'm going to type something as simple as released. That's a current date for me, and to release any drawing there needs to be some kind of set of initials or authorization to approve the release process. So I click that and I have my revision table filled out. All right, so at this point we need to put dimensions on this drawing to complete it, and put a few pieces of information down here in the title block. I'll close the chapter at this point. I hope you found this video valuable, and I look forward to seeing you in the next chapter.